Okay, so now let's do some more real examples, some more real detail examples that can show you some more situations that can arise at these problems in section 4.4. And so I'm going to look at more examples here. And this next example I'm going to look at, it's going to be actually be your homework problem for section 4.4, problem number 1. Okay, so we're looking at something similar to your homework problem for 4.4, problem number 1. Okay, and so now the equation that I have on my quartz compass problem is 3x, 3 to the x equals 81, and we would like to solve this equation here. Solve that equation here for x. That's what we would like to do. So now, with this equation, the trick, I mean, it's not really that tricky. I mean, maybe at first you're seeing, when you're starting looking at the equation here, what you're seeing here is maybe it's two different bases, right? We have 3 to the x on the left-hand side, so I have base 3 on the left-hand side. On the right-hand side, it seems like it's 81 can be acting as the base, and then that raised to power 1. However, you don't have to rush into using method number 2. Method number 2 for sure will work in this problem. However, there is actually a better way. You can still stick with method number 1. What I can see here is that 3 to the x equals 81, right? Now, 81 itself, as a side note, 81 itself, you can rewrite 81 here as a power of 3. So what power is that? I can see that 81 is power 4 of 3. Or you can think about 81 equals 3 to the 4th. So now I can substitute my right-hand side by 3 to the 4th power. So now I just automatically brought my equation back into the form that I can simply use method number 1 in solving exponential equations, because I have common base on the two sides, so it's 3 and 3. So here I have base 3. Okay, so now as long as I can show my equation to have the common base on the two sides, then what I can do is just simply, I pick the power on the left-hand side, I look at the power on the right-hand side, I equate them together, I set them equal to each other. And now right there, right at that point, I found my solutions. X equals 4 is the answer to that problem. Okay? So now, moving over to maybe like a same kind of trick that we can use. Let's look at number 2, something similar to number 2 in your 4.4 homework. And this is how you can see another equation here. And so it looks like what we have here is the equation 2 raised to the 4x, okay? 2 raised to the 4x minus 20. So 4x minus 20 is the expression involving x as a power. And that equals to 16 on the right-hand side. So once again, similar fashion how we solve the equation number 1, what we can do now in problem number 2, the number 16 on the right-hand side, okay? Even though it looks different base, it looks like it's a different base with the number 2 on the left-hand side. However, as a side note, once again, 16, you can rewrite 16 as a power of 2. So I have 16 equals 2 to the 4th power. Okay, and that would makes it, the right-hand side would now become 2 to the 4th power, and the left-hand side would, of course, remain the same, 2 to the power 4x minus 20. So now I have just once again brought my equation, starting out at looking like nothing common, but now when I brought it down to the second step, my two bases on the two-hand side, they are now the common base. We're looking at base 2 right now, okay, and it's a common base. Okay, so now as long as I'm recognizing common base, I can still use my method number 1 to solve this equation, because the point is we would like to bypass all that ugly looking taking natural log problems. So here I can just simply select my power on the left-hand side and set it there. 4x equals 20. I mean 4x minus 20. I just simply pick that power, the whole power on the left-hand side, just set it equals to the power on the right-hand side. Here I produce for myself the next equation, and that would be equals. So to solve this equation, things should be easy for us, isn't it? So add 20 to both sides, okay, and such and such. So eventually later on I'm going to have 4x equals 24, and then dividing both sides by 4, okay, that gives me x equals my third example, with all these detailed discussion here, in my third example, which is also similar to your problem number 3, homework problem number 3 in course compass, what you can do is, once again, we would like to solve, okay? And the equation I have is, this time, we want to solve 64 x equals 32. So now at this point, once again, do not stress out yet. Don't rush into method number 2 yet. We can still rewrite the equation in a way that they have common base on the two sides. So the point you can see so far, the pattern of the work here is that with the 3 problems we've tried so far, we always try to look for common base on the two sides of the equation. Common base is the key here. Okay, so now, as a side hint for here, 64, I can go all the way down to the end, and I can see that 64 is actually the power, a power 6 of base 2. So I can write 64 as 2 to the 6th power. And 32 on the right-hand side of the equations, 32 would be equal to 2 to the 5th power. So now, at this point, what I can see now is that the left-hand side, I can convert that into 2 to the 6th all to the x power. Because once again, 2 to the 6th substitute for my 64. And then the left-hand side has x as the new power, as the outer power. So I have 2 to the 6th, and then all that expression raised to the x power again. And then equals to 2 to the 5th on the right-hand side. And so now what I have here is that, now according to the rules of powers, when you have a number being raised to a power and then being raised to a power again, what you can do is you can just simply multiply the two powers, 6 and x together. And that creates 2 to the 6x power. 6x power equals 2 to the 5th. And once again, the good thing is, at this point, you can just now see that we have common base 2 on the two-hand sides of the equation. So now I can just simply look at my power on the left-hand side and look at my power on the right-hand side. I set them equals to each other, and so now solving for this problem here, what I have is just dividing both sides by 6, and I have x equals 5 over 6. And of course, I mean, I never said that we cannot have fractions, right? We will have fractions, and that's going to be quite often.